Okay, so for the first tutorial, the first question would be if everyone has downloaded the virtual image already. Okay, sorry? Okay. Okay, that's unfortunate. Yeah. So I think the first step would be okay. Okay. So the setup should be at this point quite straightforward by simply importing the image in VirtualBox and simply booting up the image should be all you have to do. Or maybe Lucas, are you here?
Yes, I am here. But I didn't hear the problem, so maybe you can repeat it to me.
Okay, then I would have to plug in my laptop. Or I can maybe simply share my screen and then
even better.
Was bedeutet? Ich bräuchte dein Mikro, brauche ich wahrscheinlich noch.
Yeah, you can just keep it and stop sharing. You start sharing and you start off. And then hopefully it should. So if you hear the screen share, then you will see what he's doing there. Hopefully that's the idea at least. It will work.
So far, so good. Yeah, exactly. So the credentials were simply Debian, and okay. So basically, to import the VM image, I'm also quickly showing it here, but it's quite small. I'm not sure if I can increase that. It doesn't seem that way. But if you click on File, you have some sort of option to import the appliance. And here you can simply select the image that we provide. And after importing that, it should be fine to simply boot up the image. So does that work for everyone? Okay. The other two? Okay. So how is it for the online audience? Okay, maybe some additional feedback to see how many are participating here. Does it only work for one person out of 24? Or are there some more? maybe the remaining 23 are still sleeping. Okay, then I'm continuing anyway. So once okay. Yeah, that the only thing you would have to do here would then just simply start. Does the audio still work? Yeah, it seems to work still, yeah.
Yes, we can hear you online.
Yeah, so the only thing you would have to do here would be to simply start up the script and execute it, and that starts the OMNeT IDE. Yeah, that's probably the projector's fault.
So you share some teams. Oh, not, okay. And you need that here. Yes, that's just what is in the room. It's hard to read now. For the Teams members, it's all better than the room. Yeah. Okay, very good.
So maybe you can have a look at their screen if that's improving, or even better. Okay. So once you have started the OMNeT IDE, we provided, or Lucas was so nice to provide you our whole project in there. So by clicking in the Project Explorer, you can open a deterministic 6G file system, and in there you have the option of the simulations. So if you open up them, you find an entry on the training day. And in here, we can then start with the first tutorial. Does that work for everyone? Okay, so far so good. And in here, in tutorial 1, we'll start. I'm first going to build a few slides on what to do. But basically for the first tutorial, it suffices to have a look at omnet.ini file and also at the network description file, which would be the first one right here. So you are free to have a look around them. But I think now I'll switch to the slides again. Yeah. Okay, so as I just mentioned, the main files that we're interested in are network description files, which have the ending NED, and the initialization files, which have the ending INI. And we'd like to start with a gentle introduction, simply to make you familiar with the environment. So the network description files basically provide us the topology of the network. So we have a talker, bridge, and listener here, for example, meaning that we have to specify what type are they. For example, the talker and listener should be end devices, and the bridge would then be a TSN bridge. And we can also specify links between them. So in this case, we would have a simple Ethernet link between talker, bridge, and listener. The second part would be the INI files, which are basically configuration files for the simulation. So in here, we basically have, for instance, in the simplest case, we have to specify the network so the network.ned file would be specified here. We can also give a limit on the simulation time. We can give a description of it as well. And then we basically have the more advanced configuration down below, which would be now sort of your task as well. So, but I will still simply try to guide you through it. So in here, we, for instance, can then specify the number of applications for the talkers, the listeners, can specify what type of application we have. So whether we have a UDP application, TCP application, and then we would also have to specify, of course, the destination, the ports, and so forth. And the first task would then be to set up the talkers and listeners to get to a more advanced stage later on in the subsequent tasks. So for task 1, once you open the first NED file in your project, you may notice that there's already a link missing between the bridge and the listener. And the first task here would be simply to add an Ethernet link at this point. I can also go through the other subtasks of task 1, and after that I'll provide you some short time to try it out yourself. So after that, the next step would be, once we have configured the Ethernet link, we then want to go over to the UDP source apps. So for the talker, we want to have 2 applications, which would be then UDP source apps, and it would be your task to specify the packet length, which we want here to be equal to 100 bytes, and the destination address as well. So your first task would be to fill in those to-dos, which are also given in the INI file. So if you open the INI file, there we also specify the to-dos, which would then be your task here. Here for subtask C, you may recall the definition of time trigger traffic from our lecture just before. So the idea here would be to specify not only the destination port, but also the production interval, so we can have certain periodic traffic patterns. And finally, a little more difficult would be subtask D, in case you are a little faster. Then you can also specify a bursty traffic type, for example, audio or video. So in here, you would also specify the destination port and production interval, but you may find it helpful to have a production interval which is not static, but you can also use different types of functions, of mathematical functions in OMNeT. And in here, you can then have some terms to specify, for example, a sine function for the production tool. And the overall goal of this task would be to have sort of this result. So we can then plot later on the arrival curves of the 2 applications. So in here, we would have the orange arrival curve for our time trigger traffic, which would be sort of linear. And we have also a bursty traffic, which follows some sort of sine curve right here. So to provide you an overview of your tasks, I'm leaving this slide open, and then I'll give you a few minutes to try to work on those tasks yourself.
So the idea is now that the people who want to work on the task themselves have now a few minute time. We change the setup, which is unavoidable anyway. And then we show you the solution. Is that correct? Is it a solution? Yes, the solution, yeah. Then everybody can follow the solution who does not want to actively participate. And you have time to work on the task and think a little bit about it if you want to participate actively in this tutorial. Would have been easier here if we were all in the room, maybe, because then we could maybe actively help also the people a little bit. But for now, I think it's the best we let you work a few minutes. Could also say you have a few minutes break in your hotel room now. And then later on, after a few minutes, we show you the solution. Okay.
Can you hear in the WebEx meeting? In the Teams meeting, sorry. I'm sorry, can you type in the chat if you can hear me? There's nothing in the chat. Depends on my maybe. So much for the screen share.
Test. Test.
Präsentation weitergeben. Ja. Genug Zeit, in der Zeit hätte ich es zweimal gemacht.
Okay, then I think we can try to start showing some results. Can you maybe show by a raise of hands if you were able to complete the tasks already? So still in task 1B, 1A? Okay. I can try to Then I'll share my screen. Okay, then in this case, I guess we can start explaining the solutions. So for the first task, what we wanted was a simple set of the listener applications and the talker applications. So here we first would have to specify the destination address of the listener, which we can simply do by writing listener, the host name in here. And what's also then what we have to do for the packet length would be to specify the 100 bytes, and because we want to consider Ethernet packets of size 100 bytes, we then have to subtract all the Ethernet header fields and so on. Because we have a UDP application, we then have to subtract the UDP packet length header of 8 bytes, the IP header length, and so on. And that would be in total minus 54 bytes, and that would then give us 100 bytes of Ethernet frame lengths. For task 1C, we considered time trigger traffic. So here, if you look up here, the local ports of the listeners were specified, and those first have to be given as the destination port, of course. And then the production interval for time trigger traffic can be set to be constant, which we would here specify as 10 milliseconds. So task 1C, which would then be only those 2 points that would have to be added. And task 1D is slightly more complex because here we do not want a constant production interval, but we want some sort of sine function to simulate some bursty traffic. So in here, we would then specify the destination port again, and could then try to come up with sort of a function of this form, which with some playing around, of course. So by giving some sort of initial function, you can then play around a little until finding some nice result here. But I guess it's a little more interesting if we start the simulation and see what happens now. So we can simply here at the top, we can click on the run button and start the simulation. And then we can select tutorial 1D to start. So if I'm scrolling here into the center of the screen, I can then start the simulation slowly to show some animations as well. And here later on, we also have the option of running the simulation a little faster to get up some nice results later on. But if I'm simply starting the animations here, we can then see, unfortunately, with a little some sort of bug by OMNeT. Which I'm unable to close. I'm sorry for that. But basically what you can show is the transmission behavior of the packets. And if you want to speed things up, so we have a simulation timeout of 10 seconds. We do not want that to run that slowly. We can press up here on Express Run, and that would then complete the whole simulation. So when we have done that, there will be some generated results. So if you would look in the results folder, you then have some files here that are generated, and by simply double clicking on them, you then get some overview. And here we already provide a chart that you can simply double click on, and that would then provide us the results that we had in our presentation slides. So here you would have to run the simulation yourselves, and then this plot would accumulate basically when the time points when frames are transmitted at the respective talker. And that would then give us this plot right here. Okay, so let's come to task number 2. And task number 2 would now be to configure simply the strict priority transmission selection. So here you can have a look at the network file again, which would now be the network file labeled task number 2. So here, compared to task 1, we do not have one talker, but we have 2. And you may remember the default models from before, where we now also want to simulate a babbling idiot failure by having the talker at the bottom sending out massive amounts of traffic. And the idea here would now be to give the upper talker still some guarantees. So the first task here would be to have a babbling talker configured to produce this massive amount of traffic. And here we also provide you some to-dos, so you don't have to provide the whole configuration yourself, but can again fill out basically the only the values as for task 1. So you would have to specify the type name, which would also be like the UDP source app again, the destination address as before as the listener. And now you can ramp up the production interval to produce a massive amount of packets. It gets a little more interesting now for task B. So for subtask B, we want to extend the queuing capabilities. So if you check out the simulation, you can click on the different network entities. I'll show that a little later on. But what we want to do now is extend the number of queues to 3 egress queues, and therefore we can then simulate the strict priority shaping. And to do that, we have to specify the number of traffic classes per bridge. So that would be then your task to set up for the TSN bridge in the middle the number of traffic classes, and you can also give them a display name if you'd like. And what's more important, however, is that we also have some stream identification. So we want to still be able to identify the different traffic types of traffic. And here we can then, for example, identify time trigger traffic depending on their source MAC address, depending on their destination port, and so on. So your task would here be to fill out the to-do and the packet filter to provide a sufficient identification for the different traffic classes. Okay, so again here an overview, and as a small hint for the subtask B, we also provide a link to the documentation. So there you're provided with an overview of the available packet filters, which may help you in subtask B. What I also want to quickly show would be the view we just had. So this view right here. I have to find that. So if you simply start the simulation as before, you can now select, I think you first have to uncomment the respective blocks. But once you do that, you can start to select this task. And in here, you can then start clicking on the individual components. And I have to zoom out. So that's a little cramped because of the presenter right here. But what we can do is we can select the Mac layers, and in here we have the option of finding out the queues. And if you have set up that correctly, you are then displayed with the view we had before on the slides. So again, simply clicking on the TSN bridge, then on the respective Ethernet port you want to look at, Mac layer, queues, and in here, once set up, you should see what we had on the slides. So again, I'll give you a few minutes so you can try that out, and then we'll come back. Okay, so I think for the sake of time, we'll start going over the results or the just possible solutions. So for task A, we basically want to have a babbling talker where we set the production interval to be quite low, so we simply produce a massive amount of traffic. So here you basically have the option of either choosing quite large packets. So here we opt of choosing the maximum sized packets of 446 bytes for the UDP packet length. So again, you have to consider that we subtract all the header sizes, header lengths. And then for subtask B, the main idea would be simply to specify a number of traffic classes to be free. We can give them different names. So we have best effort, we have bursty traffic and time trigger traffic. And the main idea, as we had before on the presentation slides, would be to have a simple mapping. So first off, we would identify the time triggered stream based on the UDP destination port. And given that mapping, we can then specify a PCP value for that stream. And this way we can then give the time triggered traffic a PCP value of 7, so being the highest one. And in contrast, we then provide the bursty traffic a lower PCP value. So here, the tricky part really is that we only have 3 egress queues, and that requires a mapping of having the 8 possible PCP values down to 3 queues, and that's specified by the standard. But here, it would suffice to simply choose a lower PCP value. So having a PCP value of 5 for the bursty traffic would then map bursty traffic into the second egress queue. Okay, I think interesting, it gets a little more interesting when we simply run the simulation. So here we then would select task 2B, simply press OK. I have to zoom out again. And now if we click on the bridge, click on Ethernet 2, MAC layer queues, and zooming out again. Here we would then have the view of before. So when we now click on run, we can now see that time trigger traffic goes to the lower Q2, which is labeled time triggered here. Bursty traffic is then enqueued at Q1. And finally, now should also arrive a best effort traffic packet, which is then set in Q0. And this way, if we have multiple best effort frames in here, we always prioritize the higher priority traffic to come first. We can also do so instead of, I think instead of giving you additional time for task 3, which would basically to configure the time-aware shaper and the credit-based shaper, I'm also simply going to show the results here. So the idea was mainly to look at what would happen if we were simply running the simulation without the QBB time-aware shaper and with the QBB time-aware shaper. And the problem here would be the simple delay. So once we have a best effort packet in our queue that is transmitted at the full, at the maximum length, that could then result in additional jitter of our time-triggered traffic, and that's something we want to avoid. So instead, by specifying the time-aware shaper, simply by opening gates only for the time-aware traffic, we can sort of allocate a transmission interval that is exclusive to the time-triggered traffic. And that would then provide us this latency right here. And the main way of doing that would be to specify simply the gate control list. So here we would specify an opening time of 10 microseconds. So actually we could go a little further down that, but we are a little conservative here, specifying 10 microseconds, and a closing time of the remaining duration until hitting a hypercycle of 10 milliseconds. So we have a production interval of 10 milliseconds, and that has to be fully specified. And the same can also be done for the credit-based shaper. So instead of having the sign function of before, which we have right here, we can then try to shape the traffic as we like. And this would then provide us the result right here. So we have a send traffic, and that could then be shaped to be at constant rate, basically. So that the blue line would be the shaped version, and that would allow us to send out the bursty traffic at a constant rate, which we can then guarantee. And we can also try to simulate that. So if I'm switching back to the simulation, simply running the simulation again. And in here, I'm now selecting 3A for the configuration of the time trigger traffic. Then we have now a nice animation that shows us when are the gates open and when are they closed. And also if we now zoom in, and start running the simulation, we then have our time triggered packets that are enqueued in Q2 as before, but now we have a reserved interval where the above two gates are open and bursty traffic can pass through, but we now also have an allocated interval where only time triggered traffic can be transmitted, and that basically provides this guard band, what we talked about in lecture 1, to isolate a specific interval where only time triggered traffic can be transmitted. Okay, so maybe I'll restart this one again, because we would have to wait until 10 milliseconds until the next time triggered packet arrives. But what we can see in the first occurrence here is that here we have a short period where time triggered traffic opens and the above two gates are closed. And by doing that, we ensure that only time triggered traffic can be sent and basically has this isolation from the remaining traffic. And I think that would be it for the first tutorial. Now I guess we have a short coffee break, and thereafter we then continue with lecture 2. So thanks for your attention.